And by golly, there is a method to the madness of you students putting this together. We have another segue coming up here. What Amy just talked about, we sort of have a way to get, not around it, as much to create a better, brighter, and using less energy future. Solar energy beyond the hype. Would you please welcome from our chemistry department, Professor Prashant Kamat. Professor?
Good evening. First of all, thanks to the Hub for organizing this very interesting and topics. I'm also learning. Okay. As you have heard in the previous two talks, energy is going to be one of the major factors in the coming years. It's already playing a big role in the next presidential election. You know, you can open up any newspaper, any media, the first news you hear is about energy. And that is for a good reason, because we have been consuming very recklessly a lot of energy devices. You know, when you buy a plasma TV, we don't care how much it consumes. And in the previous talk, you heard how just a simple iPad consumes. Even the newer iPad consumes more energy. It is heating up. Heating up means it is losing energy. So these are the factors will play a major role in our future things. So what I'm going to do today is give you in three parts. One is get the facts right. If you turn on the TV, you will hear all different kind of statistics, all different kind of things, but get the numbers right. And then you argue how it can be done. First, the simple thing. What are the energy we are talking about? You know, first in the bottom scale, on the left-hand side, you see there are more consumables. They are used in watts and kilowatts. Typically, a household uses about 5 to 6 kilowatt hours of energy per day. But to produce it, you need a centralized place. Like the windmill produces about 1 megawatt, which means you can run about 1,000 hot air dryers, hair dryers, or toasters. Same way, one nuclear plant is gigawatt. You can see that I separated out in factor of 1,000, you know, the increase in 1,000. And as a US as a whole, we consume about 4 terawatts, approximately. And worldwide, if you put into picture, we consume about 15 terawatts of energy. Sorry, worldwide is 15 terawatt. We consume about 4, approximately 25% of energy. This is all sectors, transportation, industry, household, everything. And here is a person, very smart person and very respected person. People didn't think he was very smart. And he was a geologist with a mathematical background. In 1950s, he had made a lot of prediction about energy, what we will be having today. And his predictions are coming true. And when his predictions came true in the 70s, he was, President Kennedy had him as an advisor, and he was in all these kind of commissions. But what he says is, our energy resources on this planet are solar, that is current, and stored. We often forget to realize all the fossil fuels we have is stored sun's energy. All the food we eat today is stored energy. So next time when someone tells you you cannot store energy, tell them that we are living on a stored energy. That's the biggest source. And again, he goes on to say that from the standpoint of human history, these fossil fuels will be very brief, probably around 200 to 300 years. Okay, recently there was a report came from British Petroleum's, an oil company. They give a nice statistics. You can go on the web and read more detail about it. What it tells is our current energy growth worldwide is about 2%. It's been 1.7 to 2%. And by the time we reach 2030, the energy mix is going to change. And this is not from a scientist. This is from an oil company telling you that what we are having is the oil component is going to go down and renewable is coming up. So you can see compared to 1990, it was renewables only 0.4. It's going to be 6.3% in 2030. So we have to start doing different things than what we are doing it. Just because drilling more oil wells will not help us, we have to look for alternative energy. And when you talk about renewable energy, right now in the US, it makes it only about 8%. And what you are going to see is lower in petroleum dependence and more in renewable energy. That's coming up. And another thing is, always people like to say, gas prices going up, we have to drill more wells. But if you look at the chart, there is a steady increase because the demand in the US is a little lower because we are conserving more, but China, India, and other emerging countries are consuming more. As a result, if there was a steady slope, and there was, you can see in the 2009, there was a drop in financial crisis. When it came in, it dipped down, but it is back again in the same slope. So you can predict how much will be the oil prices world market. So world market will dictate. It's not same for gas, natural gas, because you cannot transport across the ocean. So that's one of the argument. And the only people who love these high prices are the gas companies, okay? So that is the one. And the next point is, what are the options? As told by Jessica in earlier talk, the climate change is going to be a big factor. This is the fact that we collected. In the last century, our population went up 4 times. Our energy demand went up 16 times. You can see all the iPods and computers. Just 20 years back, it was not there. Notre Dame alone has about 30,000 PCs, and most of us never turn it off. It's always there on standby. So when you have this kind of energy demand, every device that you make is energy hog. So in this case, what will happen is, you see this is the hockey stick, the temperature range. This is the carbon dioxide going up. In my lifetime, carbon dioxide went up 25%. If you are a freshman here, by the time you graduate, it will be 400 ppm. It is going up 2 ppm, 2 parts per million going up. And so is the population. You can see here, all correlates very well. So this is going to be one of the factors that's going to tackle. And one of the challenges is to generate clean energy that does not have global warming gases or any other things. So what are our options? One is you can keep on burning fossil fuels for next 100 years, we are fine, you don't have to worry about. But sequester the carbon. Sequester means you capture the carbon dioxide that's coming out, bury it in the, ocean or in the mines. That is one. But you see the volume, how much to tackle. People talk about nuclear power. They don't emit any gases. But we don't know what to do with this waste fuel. But still, if you consider that is an option, you better start building 1 nuclear plant per day somewhere on this planet. Okay? That's the magnitude of energy we need. That's why China is building up 2 to 3 coal power plants every week. Another one you see is, what are the options? Renewables. If all you see here is solar energy striking Earth, 120,000, of which maybe only 20% is usable on the land, but still what we need is only 10 terawatts. So if you are looking for more energy, what will be our option? So if you consider solar energy, there are 2 factors. One is, we normally say thermal conversion. Another one is photo conversion. In thermal conversion, it's very simple. When you see the garden hose sitting outside in the summer, when you pick it up, the first water comes out, you cannot even handle that water. It's hot. Same way, you can use it for heating your houses or heating your hot water, or you can generate electricity. So there are newer thermal electricity generation plants are being built. Spain went last month with a 24/7 molten salt-based thermal converter. So they are producing solar energy in the gigawatts. The other one is photosynthesis. And if you do photosynthesis, not only for food, we can think about making biofuels and other things, and there's photovoltaics. In this case, they take the energetic photons and then use that energy either to break the bond or make the reactions, those kind of things. Okay, the last topic is energy. as Lou Nanne told, be passionate, be creative, and be futuristic. Don't be afraid to try new approaches, and that's what we are trying to do at Notre Dame and elsewhere, some other people. Because if you want to tackle the energy, it is not the way we used to do it in the past. We have to look for better opportunities that we are doing. And here it is. When you talk about solar energy, that's what we are doing research here. Our students are getting trained. And you see here, we have to capture, convert, and store. That's a three-pronged approach. Capturing, you capture with chlorophylls like plants, organic dyes. These are all colored things that will absorb light. And then you convert through a photovoltaic cell, or you can make chemical fuels. You can split water into hydrogen and oxygen. If the oil runs out, we will have hydrogen. That will be our fuel of future. We have to find a way to liquefy or doing it. There's a lot of work going on. Otherwise, you can store it in the storage batteries. That is another big thing that is taking place. And all these kind of research activities are going at Notre Dame. And you see some of the things that we are looking in particular is dye-sensitized solar cells, organic solar cells, quantum dot solar cells. These are not your typical photovoltaic cells. These are uses new materials, what you call as a nanomaterials or small diameter particles. They have unusual properties. Those are the ones we are trying to do and make the technology transformative, not the way we used to do. So we have to do it. When the memory stick came in, it wiped out all the CD-ROMs, right? Nobody uses anymore. So same way, we have to find and transform a technology, and all these undergraduates, graduate students are working in this one. For example, this could be your transformative. All the windows you are seeing. Amy can go and think about putting on an architecture building, these kind of windows that can produce solar cells. Or you can wrap around a plastic sheet on your next pillar that can produce electricity. Or you can take a paint. You can go to a Menards or Lowe's, buy a bucket of paint and just paint it and generate electricity. It can be done. So these are some of the things we are doing in our things. I'm not going to detail. These will include making solar cells, making new catalysts, especially trying to split water. If you make hydrogen and oxygen with sunlight, what we need is a right pixie dust that you can throw in a pond that can generate hydrogen and oxygen. We are all set for the future. So that's the kind of materials we need, this one. And this summer, some of you might have read in the papers and other approaches. One of the undergraduate working, we came with the idea that why can't you try something simple idea? We mix things up, make it in a bottle, and actually literally we made a paste in a bottle, applied it on a conducting surface, and made a thin film. And we even dried up in a dryer, hair dryer. And as you can see here, we could get 1% efficient solar cell. It is much smaller, but right now we can get up to 2 to 3% in that range. But we are hoping to push it up to 7, 8%. You can think about the simplicity. We don't need any clean rooms. We don't need any heavy equipments, just simple approaches. These kind of transformative technology. And this is the way to think big. And one of the things is, over the last 20 years, the per kilowatt price of photovoltaics has dropped from $500 to less than $2. Thanks to Chinese, okay? They are bringing in competition. But think what the next 20 years will bring. Thank you very much.
And Professor Kamat, we thank you very much as well.